Thanks very much for that introduction. That was pretty cool. Okay, so hopefully everybody's having fun today, right? So we start off, Greg gave us, past, present, future of Singularity. That was a pretty fun talk. Now Eduardo gave us, how to do Singularity things in Singularity 3.0. It's my distinct pleasure to be able to talk about some of the new features, not only of 3.0, but also 3.0 and beyond. And that's because actually last month, we already released 3.1. That's got a whole slew of new features. And we've got a roadmap. We have a lot of features coming down the road, so I want to talk about those real quick too. Okay, so the punchline of my talk, if you take nothing else away from it, is that the 3X series of Singularity is basically awesome. Okay, so as Greg said previously, this is pretty much a complete rewrite of Singularity from the ground up. It used to be written in C, Python, and Bash. Now it's written almost all in Go and C. It's got a ton of new features. 3.0 was released with a ton of new features. One of these I'm going to be talking about a little bit is the Singularity Container Services, SCS. So this is something that Sylabs put out with 3.0. We're very proud of that. It's got 3 different parts. The first of those is the container library. This is a place to host your containers, to download others' containers, to distribute them. The second is the remote builder. So you can actually now build Singularity containers using Sylabs infrastructure without having root. And the third is the Keystore. So we've talked a little bit about signing and verifying containers. This is a place to store your public PGP key material, allowing other people to verify your containers, or allowing you to verify containers which are made by other users. All of these SCS services are fully integrated into the command line too. So I'll give you some demos of that today. SIF, the Singularity Image Format. Oh, and the SCS, the Singularity Container Services, I should point out contributions from Adam Hughes, also from Dave Trudgian, and several other people as well. The SIF, the Singularity Image Format, is now the default container format. We've talked a little bit about signing and verifying containers. Eduardo gave a lot of great information about how that's made possible by SIF. So this was the work of Yannick Cote and is maintained now by several other people as well. Network virtualization provided through CNI plugins. So now with Singularity 3.0, we have full-on network virtualization using the same tools which are used by Kubernetes. So that's that CNI plugins. And this was the work of Cedric Clerget, primarily. We also have now fine-grained control over the Singularity security context. So we talked a little bit earlier about the ability to add specific Linux capabilities, allowing users to have specific capabilities within a container. And Singularity now is also integrating with things like SE Linux, AppArmor, and SecComp. So this is the work primarily of Michael Bauer and also of Cedric. And we also have native support for C groups now, so it's no longer necessary to rely on resource manager like Slurm or PBS. If you want to limit your container's resources, you can do that right within Singularity. Once again, that's the work primarily of Cedric. And finally, we've got the ability to, it's much cleaner and easier now to work with Docker and OCI containers. So you no longer have to, if you've got a Docker container, you don't have to like push it to a local registry or push it to Docker Hub or something like that. You can build directly from a Docker container which is running in the Docker daemon. And so this was the work primarily of Ian Kaneshiro. Okay, so 3.1. 3.1 came out last month. That was all just 3.0, right? Which came out last October. Whole slew of new features. 3.1 came out last month. And it adds, the feature set is a little bit smaller, so it's a little bit more manageable. But the big new feature is OCI support. What does that mean? Well, now there is a way to run the Singularity runtime in an OCI compatible variant. So there's an OCI command group, and it adds all of these commands. Not only can you run Singularity in an OCI compatible way, but you can also mount CIF files and expose them to the file system as an OCI bundle. In parallel with this effort, so that was the work also primarily, well, of two people, Sasha, I'm going to mess her last name up, Yakovtseva. There's a lot of consonants, I'm sorry. That was her work primarily, and also Cedric's work. In parallel with this, she was also working on the Singularity CRI. So this is a shim for Kubernetes, allowing you now to orchestrate Singularity containers through Kubernetes. And that was actually released in alpha just about a week ago. So now it's completely possible using tools which are free to download to schedule and orchestrate Singularity containers through Kubernetes. And now we get to the and beyond part of the talk. So I want to talk a little bit about the things that we've got on the roadmap. We're working on a plugin framework, allowing third parties to develop tools as plugins for use with Singularity. So I know a lot of people are really excited about that. We're working on multi-stage builds. So it's going to be, you're going to be able, in a single definition file, to be able to build multiple containers, to have a development version of that container, to copy binaries from the development version of the container into another container and make a really slim, svelte container that only has a single binary in it. We're working, and Greg kind of mentioned this a little bit earlier, we're working on encrypted containers. Those containers will be encrypted while they're being transferred, they'll be encrypted at rest, and most importantly, they'll actually be encrypted while they're running. So they'll mount to the loop device encrypted. We're working also on transparent Windows support. So it's going to be, you're going to be able to run Singularity on a Windows machine through something like Hyper-V, so a thin layer of virtualization. And as Greg pointed out earlier, we're also working on transparent Mac support through Xhive, so a thin layer of virtualization allowing you to run Singularity directly on your Mac. And in fact, ta-da, we actually, that's not something that we're still working on it, but it's already been released in alpha preview, so you can do this today. Okay, and hopefully towards the end of my talk, if I have enough time, I'll go through a demo of how to do that. Okay, so now I'd like to get into just some demos a little bit. I'm not as brave maybe as Eduardo, so I pre-recorded my demos. So hopefully, and I got a lot to get through really quick here too. So as I already alluded to, we have the Singularity container services now. There's the remote builder aspect, which allows you to build a container on our infrastructure from your command line without using root. There's also the container library, which gives you a place to store, distribute, search, and download your containers. So after you build those containers, you can either push them up there or you can push them later. There's the Keystore, which is a place to store your public PGP key material, allowing others to verify the containers that you push to the library. And altogether, these three pieces provide an end-to-end solution for packaging and distributing software in trusted containers. So if you think about it, this is kind of doing for containers what RPM and deb repos do for source code. It's just a way to distribute these trusted containers. So let me give you a little demo of what this looks like now. Hopefully everybody can see this. So notice I've got two different users here. I've got one that I'm calling author, and then one that I'm calling end user. So the author is the one who's writing the container, the end user is the one who's ultimately going to use the container. So the first thing I need to do, I'm going to show you I've got a definition file, and I'm going to use the build command to create a container called foo.sif from that definition file. This is an Alpine definition file. You'll notice I used the remote flag here, and you'll also notice that I didn't start this command off with sudo. So there was a question earlier about, why does building containers require root privileges? And the answer is it no longer does. So now what's happening behind the scenes is that Singularity is reaching out to the remote builder, and the remote builder is spinning up a VM on behalf of the user in which to build this image. I'm going to fast forward because that takes a few seconds. And you'll notice once the build actually starts, the information is echoed back to the screen, so it looks as though the build happened locally, even though it happened on the remote builder. Now, if I list the files that I've got in my directory, you can see I've got this container that I've built. And so the next thing now I want to do is I want to assign that image. That's very simple. I just go singularity sign foo.sif. Once I enter that command, it's going to say, oh, you don't have any PGP keys. Do you want to automatically create one? I'm going to say, yeah, sure. I'm going to enter my name, a little bit of information. I'm going to enter my email address. Critically, that email address, so I have to be signed in to the SCS, the Singularity Container Services, for this to work. And that email address needs to match the one that I use to authenticate. So here's the bit of trust there. It's going to ask me if I want to upload that key to the SCS. I did. And so now the only thing that's left to do is to push that image, foo.sif, up to the library. Now you'll notice that when I did this, I made a little bit of a goof. So I'm pushing the file foo.sif. I'm going to push it to the following URI. It's my username. It's just going to be demo. And then I actually said foo.sif. What I probably should have done instead is just say foo. So now that repo or whatever is going to be named foo.sif. That's going to make things look a little funny later on, but whatever. So now I've pushed that up to the library. So now I'm going to switch to the end user. This is a different user now. This is a user which is interested in foo containers. So I'm going to search for foo.sif. And I'm going to see that there's no users, no collections, but there is actually a container called foo.sif on the library. And it's going to very conveniently give me the entire URI that I need to download that. So I'm just going to copy and paste that. And that's going to work with a Singularity pull command. So now I can do Singularity pull. And I can pull that foo.sif image. This is where things are going to get a little bit funny because it's going to name this image now foo.sif_latest.sif. So that's a little unfortunate, but whatever. And now I'm going to verify that image. So all I have to do is just Singularity verify the name of the image. It's going to say you don't have the right key. Let me grab the right key for you. And then after it gets the right key, it's going to tell me that Dave Godlove, d@sylabs.io, was the one who created that image. So this is the entire workflow from building, signing, downloading, and then verifying that image. Cool. And now the other thing to keep in mind too is I like to do things through the CLI. Maybe you do, maybe you don't. If you don't, that's fine. You can actually use the remote builder directly from a web GUI. So you can compose definition files directly on our website. There's a linter. There's syntax highlighting coming very soon, all kinds of stuff like that. It's really nice. Or you can just upload your definition files, drag and drop them, whatever. And then once you're ready to go, you just press that build button and it takes off. This is what the container library currently looks like. One of the nice things about the container library is that it assigns a unique SHA-SUM to every container that's built, and you can use that to pull the container later. So if reproducibility is the name of the game, that's what you're trying to accomplish, you can do that with that SHA-SUM. And here's what the Keystore looks like. I think that Eduardo kind of already showed you the Keystore. This is the one piece that you can't actually do through the web GUI. You have to sign your containers locally, and that's because we don't store your private PGP key material. That's a security decision. Okay, so next I want to talk a little bit about network virtualization and give you yeah, got a question?
Before we jump there,
sure.
In the user workflow, I as a user would like to build a 1 GB
Yeah, so the question is about if you have 1 gig container and it's up in the library and then you've got 1,000 different nodes, you don't necessarily want to pull that container to 1,000 different nodes and run it. So there's some ways around that. So, one thing that we do is caching. I think Eduardo showed you a little bit earlier about how your containers will be cached. So if your home directory, for instance, is on a shared resource, then you would be actually then running that container from your shared file system. That's another thing. Probably all these nodes do have a shared file system, so it'd probably be better to download to that shared file system and then run everything from that. Yeah. Okay, so yeah, you can still build containers locally. You don't have to use the remote builder. If you do use the remote builder, it's automatically going to download that container back to you. So you don't have to download it from the library. You can just, push it around. So yeah, there's lots of different flexibility in that. Yeah, I think you got to hold it real close.
Question I was having in general about pulling things from various repositories. Is all of this going over HTTP and HTTPS?
I believe so.
So one option for a lot of these cases is Squid Proxies, right? So we could run and set Squid Proxies within our hosts, which is something like, for example, the OSG does with their CVMFS file system. So if you're worried about pulling down a lot of containers, set up and configure a Squid Proxy within your institution, train the users, whatever config, and make things go super fast.
You said CVMFS. So Dr. Dave.
One more question, then we're going to let Dave get through his pitch as much as possible,
Thank
and we'll
you.
have to take questions after the session.
Okay.
Yeah, so if you're taking full containers down through Squid, that's not going to work well. Squid is we use it, we take just the pieces we need, the CVMFS, so it's much different than taking entire containers down to large numbers of nodes. That's not going to be working well.
So yeah, one more question. This gentleman had his hand up.
Yeah, hold on, Jerry. Wait, hold on. Microphone. Right behind you here.
Oh, can you define your own remote builder?
Oh, great question. Can you define your own remote builder? As of right now, no. We're talking about that. So we currently don't have continuous integration set up between something like GitHub and the remote builder. We're talking about how best to accomplish that. Currently, it seems like the leading idea is to have a configuration directory, which has maybe like a series of TOML files or YAML or something like that in it, and does things like defines the some things about the remote builder, and also defines which files you want to build. All right, yeah, I do have a lot to cover, so I better get it in gear and hurry up. Okay, so network virtualization. So it used to be in 2.x, if you passed the -- net option, then you entered the new network namespace, and then you were on your own, right? You had access to the loopback device, and that was it. Now, by default, we're going to be creating a bridge network, a bridge interface between your host system and your container for you by default. You can specify, so this is infinitely configurable. You can specify really simple, really complex configurations. You do this with JSON files, and I'll show you some examples of that. There's also some convenience options for doing things like altering the host name inside the container, or the DNS, or whatever. And then finally, you can pass arguments directly to the underlying CNI plugins. So really, anything that CNI can do, you can do through Singularity. Okay, so let me give you a quick demo of this. First thing I'm going to do is just show you my IP address on my host. This is kind of a silly little example, but I'll go through it really quickly. The second thing I'm going to do is I'm going to enter a new network namespace. You'll notice I do this as sudo because we're going to be setting up some interfaces and things on your behalf. There are ways to turn this behavior off if you prefer the old behavior. But by default, this is going to go ahead and set up a bridge interface for you and a new IP address inside the container. Let's say I don't like that network configuration. I want a different network configuration. I can pass instead, so I'll use -- net to enter the new namespace. And then I will use the network option to specify the configuration I want. And I'm going to use PTP, which is peer-to-peer. And then I'm just going to look at my IP address again. You're going to notice that it's a different one. How does that work? How does that peer-to-peer configuration get applied? Well, if you look in user local etc Singularity network, you're going to see some configuration files. These are provided to you as a courtesy. These are just kind of default configurations which might work for your needs. You can create your own configuration files also if you want. You can make those as complex as you want. This is what the configuration file looks like if you're interested. And so you can create your own configuration file, and then you'll have different networks available to you that you can use. And then, so for one final example here, I want to show you, this is something that's really, really popular to do with containers. I'm going to show you port mapping now and how that looks, well, one way that could look with Singularity. I'm going to start a Nginx container. And when I do that, I'm going to use the network args option argument pair to pass arguments directly to CNI. And so the way I'm going to do that is going to be port map equals 8080 on the host to 80 TCP within the container. And so this is going to port map port 80 within the container to 8080 on the host. I'm going to start an instance running Nginx from Docker. I'm going to call that instance web. Now I actually have to start Nginx running within that instance. I'll do that with the instance : / nomenclature or syntax, and I'll pass the command Nginx. So now I've got Nginx running inside the container. I've got I'm hosting Nginx inside the container, and if I curl my local host now and notice that's port 8080, I can actually see Nginx running. Singularity's got lots of new security features. 3.0's got lots of new security features. We already talked a little bit about the capabilities command, so I might kind of skim through that a little bit more quickly. And also there's the ability to leverage things like, once again, SE Linux, AppArmor, setcomp. If these are installed on your host system, you can now leverage them within your container. And so maybe I'll give you a quick example of how to do that. Oh, we got 5 minutes, okay. I might not give you a quick example of how to do that. We'll see. So yeah, so real quick, I mean this works also with configuration files. So right here, what I'm doing, I've got a configuration file called nomakedir.json. If we look at it real quick, basically what I'm doing is I'm blacklisting the makedir command. This is kind of a silly thing to do. It's just a silly little example. And so then if I shell into the container and I apply with the security option argument pair, I apply setcomp and then I point it to that file. And then I'm going to run just an Ubuntu container from our container library. And if I do that and then I enter the container and I try to execute the command makedir, it's going to tell me I can't do that. And so why would you want to do this? Well, a use case, actually a better use case would probably be whitelisting commands versus blacklisting commands. Let's say you want to start up a bunch of instances. You got like a microservice thing you want to be doing. You want to start up a bunch of instances running on AWS or something, and you want to make sure each one of those containers can only do one thing, because you don't want somebody to be able to get onto your system and start messing around with your containers and executing arbitrary commands in them. So this would be a way to do that. Also, we have native support for C groups. This works kind of the same way. So you use a configuration file, then you apply that configuration file at runtime. So we've got a configuration file for you, which has basically everything. So this just gives you an idea of all the different things you can do with C groups. But your actual configuration file might look actually very, very simple. So here I've got a configuration file to limit the amount of memory in my container to 0.5 gig. And so then to do that, I just point it to the configuration file here. And then if I actually look inside sysfs cgroups memory at that actual parameter, you can see that my container is limited to 0.5 gig. Okay. Better Docker OCI integration. I think I'm going to skip this one just for brevity. Basically, the idea is if you've got Docker installed, you got a container running under the Docker daemon, you can build it directly from that Docker daemon. This is all on our website, thanks to Ian, who documented all of this. So you can figure out how to do it on the website. The big thing that I want to talk about here at the conclusion of the talk is that Singularity Desktop support for Mac OS is here. So if you go to Sylabs.io/Singularity-desktop-Mac OS. So if you go there, I'll give you a minute to go there. If you go there, you're going to find that you can download a tarball, extract the tarball, run a script, and suddenly you can run Singularity on your Mac. It's pretty much that simple. What does that look like? Okay, well, I just happen to have a Mac here. I promise this is actually a Mac, so I didn't just mess with my PS1. So there you go. We're running Darwin, totally a Mac. But you'll notice I can do something like Singularity Help. Woo! And it tells me that Singularity is a Linux container platform optimized for high-performance computing and enterprise performance computing. Okay, that's pretty cool. Fine. The command line interface works. Can I actually do anything with it? Sure. So I've got an alpine.def file. Once again, I can use the remote builder. So I singularity build -- remote. An alpine CIF file from that alpine def file. I'm going to fast forward because it's going to take a little while to allocate that resource and get that build completed. Now I've got the CIF file. It's red. It's kind of hard to see. Sorry about that. And I can shell into it right there on my Mac. And cat etcos release, we're running Alpine. That's simple. So cool. So this is kind of special because we're unveiling this right here at this meeting. Yeah, right on. Woo! All right, hopefully I've got a few minutes to answer questions. Yes, sir.
In that example, and the C groups, so you're running some command, some code that passes the memory limit. Does it get an kill signal, or what does it happen to my thing inside Singularity?
Yeah. So I'm pretty sure the ohm killer will take care of that at that point. So the out-of-memory killer will kill anything that exceeds the memory and C groups.
Okay, let me rephrase my question. So I have 100 or so workflow job in a batch system, and I'm using Singularity, and I guess I want to use this to control which ones get out of memory. Will I get something in the standard output or standard error to know that, oh, this job 15 got killed because it got too much memory?
So if you're using a batch scheduler, you probably wouldn't even use the C groups option because your batch scheduler, probably most of them, are going to use C groups on your behalf already to limit Singularity. And Singularity, unlike other container platforms, doesn't escape the resource manager when you start it on a remote host. So it's actually going to respect the C groups parameters that are set by the batch scheduling system.
We got one more time for one more question over here.
You skipped the OCI compatibility topic. Could you give a short summary whether it's supported and what's the status?
Yeah, I'll give a short summary, but I don't want to steal the thunder from my friend. I should have mentioned Michael Bauer is actually going to give a talk about this tomorrow. So I don't want to steal his thunder, but I will give a short summary. So yeah, it is supported. The OCI compatibility bit was released in 3.1, which is the current release of Singularity. So that's supported. Singularity CRI is still in alpha. So it's, you probably don't want to run it for production jobs, but we totally want you to, start playing with it, finding bugs, raising issues, doing all those sorts of things as much as possible right now. Absolutely. Yeah, we're doing it every day.